All right, welcome back. Here were your two evaluation questions that you had to do on your own there. And so here we go. This is the fourth root of 625, which turns out to be 5. And then we've got the fifth root of negative 243, and that turns out to be negative 3. If you had a hard time with that evaluation, please make sure you ask a question before moving on. But let's go ahead and look at the next set of examples here. And we're going to talk about rational exponents. And when we say rational exponents, remember a rational number, rational means can be a fraction, right? It can be whole number too, but it means it can be a fraction. And so really that's what we're talking about here. If we have a number that has a fractional exponent, what does that mean? And as it turns out, what it means is that it's the root, right? That's the relationship here. We can use the power rule backwards to show that a to the 1 over n to the mth power, that these are the same thing. Remember, power to a power, we multiply exponents. 1 over n times m is m over n. But what that really shows us is that the nth root of a to the m power. So the denominator of the fraction is the root. This denominator, whatever it may be, it's the root of the fraction, and the numerator is a power. So the denominator of this fraction is the root, and the numerator is the power. For example, if I had something up here that was 4 to the 1/2 power, that would be the same thing as the square root of 4. Or if I had 8 to the 2/3 power, that's like saying the cube root of 8 squared. So the denominator is the root and the numerator is the power. And it's good to point out here two things. Number one, this denominator is a 2, but notice that I didn't write a 2 there because that's a square root. We've never written a 2 there before, and we're not going to start now. Okay. The other thing that's important to point out is the names of these. This right here we call rational exponent form. And this one here we call radical form. I've been using the word root to describe these things, but this actual this symbol is a radical symbol, and it's how you describe any of the possible roots. So we can go back and forth between these forms because looking at just the root, this tells me that the denominator of the fraction is 2. And the power is 1, whereas this one tells me that the denominator of the fraction is 3 and the numerator is 2. So it's something that we can go back and forth. There's another rule here that basically says the same thing, but just as a kind of a reminder here that when we have a negative exponent, all the negative exponent does is causes a reciprocal. And so if you have something that's negative, you just got to remember negatives make reciprocals, flip your n solution. I don't know why I write an m there. That should be a to the m power. So let's go ahead and do some examples though here. So we have 16 to the 3/2 power. I want to turn that into radical form. And the radical form is, so there's 2 is the denominator, and so that's a square root. And then I'm taking that of 16, and then I'm cubing it. So I changed it into radical form, and now evaluate just means find out what number this is. Well, the square root of 16 is 4, and 4 cubed is 64. So 16 to the 3/2 power is 64. What about this one here? It's negative, so I know that I'm going to have to flip it eventually. Let's go ahead and turn it into radical form. Denominator is 5, So this is the fifth root of 32. And then the numerator is 3, and I'm going to put negative 3 there because I haven't flipped it yet. So that means that what I'm looking at here is 1 over, and then the fifth root of 32 is 2, so this is 2 cubed, and that's 1 over 8. So we can evaluate these rational exponents a little bit easier by first turning it into radical form and then using that knowledge to then find out what those values are. All right, that's it for this one. Again, we've got a couple of problems for you to do on your Canvas, so go ahead and check that out and do those, and we will see you in the next video.